Welcome again to Astronomy Daily. I'm Steve Dunkley, your host. It is the 26th of February 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Oh, it's great to be back with you again. It's been an exciting week. NASA's been busy. Everyone's been busy. There's new hardware on the moon. It's a fantastic week. Lots to report on. And joining me here to tell you all about it is the fabulous digital reporter. Here's Hallie.
Hi, Steve. It has been a big week and great news that they've finally made a successful soft landing on the moon.
Yes, that's right. Odysseus transmitting from the South Pole region. A nail-biting finish to the landing, but a successful landing after a few tense minutes. And we'll take a look at that later on.
And aren't you glad they aren't dropping their satellites in Western Australia, Steve? ERS-2 finally came down on the weekend.
Yes, I'm glad they're not dropping things on Australia anymore. Yes, I remember Skylab came down years ago, and it was much bigger than ERS-2. ERS-2 was as big as a bus. Skylab was much bigger than a bus. But I believe there were people finding bits of Skylab for years and years afterwards. You could go out into the desert and do prospecting if you knew where to look, and you could find bits of Skylab. I think the chances of finding it now are pretty slim.
But finding pieces of it now would be harder than finding gold out there in the desert.
Well, that's very true. It's probably easier to find precious metals and opals and things out in the desert rather than space debris.
I haven't heard of any finds lately.
Yes, maybe the Skylab or space debris rush is over in Western Australia. You never know, something might turn up.
And Blue Origin's New Glenn rocket has finally made an appearance on the launch pad at Florida for ground testing.
I was wondering when Blue Origin was going to make a showing. It's been a while.
I think William Shatner played with the controls a bit too much while he was up there, and they've taken this long to sort it all out.
Really?
Really?
I mean, really?
No, not really.
Okay then, silly girl. Hallie, will you boldly go and read the first few stories then?
Okay, away we go. As SpaceX nears its first Starship launch of 2024, possibly as soon as within 3 weeks from its Starbase facility in South Texas, the company is pressing regulators to increase its cadence of flights. During a press availability this week, the Administrator for Commercial Space Transportation at the Federal Aviation Administration, Kelvin Coleman, said the agency is working with the company to try to facilitate the Starship launch licensing process. He said, "They're looking at a pretty aggressive launch schedule this year," and added it would be at least 9 launches this year, which is a lot of launches. Coleman observed that it would be a lot of work to do modifications one by one, and that they have been talking to SpaceX around the clock to figure out how to do this. After SpaceX decided to launch and attempt to land its Starship vehicle in Texas about 5 years ago, the company had to undergo an enhanced environmental review of the site. As a part of this process, the FAA completed a final programmatic environmental assessment in June 2022. Following that review, SpaceX received approval to conduct up to 5 Starship launches from South Texas annually. An FAA official confirmed that the company is seeking a modification of this 5-launch limit to accommodate a higher flight rate. SpaceX launched its first Starship vehicle, which is the largest rocket ever built and is intended to eventually be fully reusable, in April 2023. That flight caused serious damage to the launch site near Boca Chica Beach and raised environmental concerns after it kicked up large chunks of concrete and dust into the surrounding wetlands. Coleman said the anomaly investigation and regulatory review process after that flight took about 6 months, which he believes is commensurate with the work involved. The company's second launch attempt in November was more successful, as the first stage booster, Super Heavy, had a mostly nominal flight, and the Starship upper stage managed to separate from the booster before it experienced an anomaly and was lost. There was no damage on the ground this time. The work entailed by the FAA for this anomaly review was about 1/3 as much, Coleman said. SpaceX founder Elon Musk has said his company is now targeting early to mid-March for the 3rd launch attempt of Starship. This flight of the highly experimental vehicle, Musk said, has a reasonably good chance of successfully reaching orbit. Coleman said that, from a regulatory standpoint, that timeline sounds about right. Anyone who has tracked the development of Blue Origin's New Glenn rocket has been waiting for signs of progress from the usually secretive space company. On Wednesday, engineers rolled a full-scale New Glenn rocket, partially made up of flight hardware, to a launch pad in Florida for ground testing. The first New Glenn launch is almost certainly at least 6 months away, and it may not even happen this year. In the last few years, observers inside and outside the space industry have become accustomed to the nearly annual ritual of another New Glenn launch delay. New Glenn's inaugural flight has been delayed from 2020 until 2021, then 2022, and for now, is slated for later this year. But it feels different now. Blue Origin is obviously moving closer to finally launching a rocket into orbit. Jeff Bezos, Blue Origin's founder, was at Cape Canaveral to see his giant new rocket on the launch pad for the first time. "Just incredible to see New Glenn on the pad at LC-36, Bezos wrote on Instagram. "Big year ahead. Let's go." Starting late last year, Blue Origin officials doubled down on the company's plans to launch the first New Glenn test flight by the end of 2024. This messaging coincided with the arrival of Dave Limp as Blue Origin's chief executive, replacing Bob Smith, whose 7-year tenure included the first human suborbital flights on the company's New Shepard rocket. Smith's time as CEO was also marked by repeated delays on the New Glenn rocket. Limp is pushing Blue Origin to move faster, and it seems the company's employees got the memo. In December, the company rolled elements of the New Glenn rocket from its factory just outside the gates of NASA's Kennedy Space Center to a final assembly hangar located about 9 miles away at Cape Canaveral Space Force Station. Inside that building, technicians connected the first stage booster, which is flight hardware, with an upper stage Blue Origin has set aside for ground testing. The final piece of the rocket to be added was a 7-meter payload fairing, the uppermost section of New Glenn designed to protect spacecraft during the initial phase of launch. Last week, Blue Origin lifted a structure simulating the rocket's empty mass vertical using the Transporter Erector arm at Launch Complex 36, a former Atlas launch pad Blue Origin took over in 2015. This was a final validation of the lifting arm at LC-36 before Blue Origin put a real, or mostly real, rocket on the pad. On Wednesday, ground crews rolled a fully assembled New Glenn rocket out of the hangar at LC-36 and up the ramp to the launch mount. Then, the hydraulic lifting arm raised the 2-stage launcher vertically. At more than 98 meters tall, New Glenn is one of the largest rockets ever seen on Florida's Space Coast, roughly the same height as NASA's Space Launch System rocket and nearly as tall as the Saturn V used in the Apollo program. The appending is one in a series of major manufacturing and integrated test milestones in preparation for New Glenn's first launch later this year, Blue Origin officials wrote in an update on Wednesday. The test campaign enables our teams to practice, validate, and increase proficiency in vehicle integration, transport, ground support, and launch operations. New Glenn can haul nearly 45 metric tons of payload into low Earth orbit. For low-altitude orbits, this is a weight class above the uppermost capability of United Launch Alliance's Vulcan rocket or SpaceX's Falcon 9 rocket but below SpaceX's Falcon Heavy. Blue Origin also plans to use the New Glenn rocket to launch lunar landers to the Moon for NASA's Artemis program. New Glenn's first stage booster is reusable and is designed to land on an offshore barge in the Atlantic Ocean, which will bring it back to the coast, similar to the way SpaceX recovers its Falcon 9 booster. The fairing is large enough to hold 3 school buses, Blue Origin said. Its reusable first stage aims for a minimum of 25 missions and will land on a sea-based platform located roughly 1,000 kilometers downrange. Blue Origin is now 24 years old and employs around 11,000 people at locations around the country, with major locations in Washington, Texas, Florida, and Alabama. While the company has not yet launched anything into orbit, Blue Origin is working on a wide range of projects aside from rockets, including cargo and human-rated lunar landers for NASA and a space tug that could move payloads into different orbits for the U.S. military. New Glenn is crucial for all of these plans. Blue Origin's latest progress with New Glenn comes as Bezos' space company appears to be on the verge of buying United Launch Alliance from Boeing and Lockheed Martin. If all goes according to plan, Blue Origin should complete the integrated tanking test within a few weeks. The rocket will then roll off the launch pad to allow technicians to install the booster's engine compartment with the 7B4s. New Glenn will also need a new upper stage before returning to LC-36 for a hot fire test of the 7B4 engines, a milestone Aviation Week said is scheduled for this summer. Blue Origin initially plans to operate with a rotation of 4 reusable New Glenn boosters, each flying as often as every 30 days, according to Aviation Week. The company has not announced a firm schedule for the debut of New Glenn other than sometime later this year. The first New Glenn test flight will likely carry a pair of small NASA satellites bound for Mars, an agency official said in November. This NASA mission, called Escapade, is on contract with Blue Origin for a launch date in August 2024. However, this schedule is under review. New Glenn's massive lift capability is overkill for the 2 Escapade spacecraft, each about the size of a mini-fridge, so engineers are studying the possibility of using New Glenn to send the missions directly to Mars rather than launching them into an initial orbit around Earth. Changing the trajectory for Escapade would allow for a launch date later this year. The mission must launch in 2024, with Earth and Mars in the right positions in the solar system, or else wait until 2026. It is worth noting that launchers comparable to New Glenn, such as SpaceX's Falcon 9 and Starship, ULA's Vulcan, and Japan's H3, took between 1 and 2 years to get to a first flight after their first full-scale test vehicles reached the launch pad for fit checks and fueling rehearsals. This final phase of a rocket's development can often uncover problems that went undetected during manufacturing and component testing. However, Jarrett Jones, Blue Origin's vice president of New Glenn, told Aviation Week he is confident in flying the rocket this year. "We're launching this year. It's happening," Jones said. "Our plan is to launch twice this year." And now it's back to you, Steve.
Thank you very much, Hallie, for those great stories from the Astronomy Daily newsletter, which you can get each day in your email by visiting these places. Bitesz.com, that's BITESZ.com, and spacenuts.io, and dropping your email address in the slot provided. Then you'll be up to date with all the news about space, space science, and astronomy from all around the galactic neighbourhood. And while you're there, check out the back editions of Astronomy Daily and Space Nuts, featuring Andrew Dunkley and astronomer at large Professor Fred Watson of the Australia Observatory. We can also be found at the Space Nuts podcast group on Facebook, and look for us on Spotify to listen in the car. Happy listening, everybody.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
And as we were talking earlier on in this episode, you will know that over the weekend, a dead satellite plummeted back to Earth, bringing an end to, get this, a nearly 30-year life in space. The European Space Agency's remote sensing 2, that is ERS-2 satellite, re-entered Earth's atmosphere at 12:15 Eastern Standard Time over the Pacific Ocean. The fall ended nearly 13 years deorbiting campaign that began with 66 engine bursts in July 2011, depleting the spacecraft of remaining fuel. And at the time of reporting, it was unclear if any debris made its way down to the surface after ERS-2 re-entered the atmosphere, but none of the fragments contain any toxic or radioactive substances, ESA assured the public in a FAQ published prior to re-entry. Now, just in case you don't know, ERS-2 was roughly the size of a school bus and weighed about 2,516 kilograms when full of fuel at liftoff all those years ago, and when it fell to its fiery demise yesterday, fully depleted, it weighed in around 5,057 pounds. That's 2,294 kilograms. While fairly large, the satellite's mass isn't an outlier when it comes to re-entered space junk. An object of similar size falls to Earth into Earth's atmosphere every few weeks. When it launched, ERS-2 was quote, the most sophisticated Earth observation spacecraft ever developed and launched by Europe, ESA wrote in its FAQ about the re-entry. The satellite was designed to collect data about Earth's land masses, ice caps and oceans, and even helped monitor the aftermath of natural disasters. Things like a Taylor Swift concert being rained out, I would imagine. The ERS satellites have provided a stream of data which has changed our view of the world in which we live, ESA's Director of Earth Observation Programs, Simonetta Celli, said in a statement. They have provided us with new insights on our planet, the chemistry of our atmosphere, the behaviour of our oceans, and the effects of mankind's activity on our planet, of course, creating new opportunities for scientific research and applications. ERS-2 fell to Earth in what is known as a natural re-entry. You and I would probably call it a plummet, meaning mission controllers had no way to manoeuvre, otherwise control this satellite during its descent towards the atmosphere. Its batteries were discharged prior to re-entry and all electronic systems were deactivated long before it began its fiery descent. ESA representatives said these types of re-entries are perfectly safe, even if some debris occasionally reaches the actual ground. In the 67 years of spaceflight, thousands of tons of artificial space objects have re-entered the atmosphere. Pieces that make it to the surface have only rarely caused any damage, and there has never been a confirmed report of a human injury, said ESA in a statement. Now, I can remember Skylab coming down in Western Australia, and it caused no damage at all, as far as I can tell, or as far as I can remember. While any natural re-entry such as this has a chance of dropping debris into Earth's surface, the chances that any remaining debris could harm people or property on the ground are incredibly low, ESA's FAQ about the re-entry notes that one's chances of being struck by lightning are 65,000 times higher than one's risk of being struck by space debris in a lifetime. And to put that another way, the odds that any one person is hit with falling space debris each year is 1 in 100 billion, they say. Are we feeling comfortable, are we? Well, the big story this week is Odysseus, a robot lander built by Houston-based company Intuitive Machines, touched down near the lunar south pole of the moon. It was a landmark moment for space exploration. No private spacecraft had ever soft landed on the moon before, and an American vehicle hadn't hit the great dirt softly since NASA's crewed Apollo 17 lander did so in December 1972. And what a happy administrator of NASA Bill Nelson was when he exclaimed on the air, I watched this, "What a triumph, Odysseus has taken the moon." He said in a video message the agency aired just after the confirmation of a successful touchdown. This feat is a giant leap forward for all humanity. Stay tuned. It was a nice message. The moon was a frequent target for American spacecraft during the 1960s and early 1970s. This push didn't come from mere scientific curiosity. Landing astronauts on Earth's nearest neighbour was viewed as a national security imperative, a way to demonstrate technological superiority over the nation's Cold War rival, the Soviet Union. The US famously put 12 astronauts on the lunar surface over the course of 6 Apollo missions from 1969 to 1972. With the moon race thus definitively won, NASA was directed to focus on other goals for its human spaceflight program, chiefly the development and operation of the Space Shuttle program. The US launched a number of robotic moon probes after the Apollo era. NASA's sharp-eyed Lunar Reconnaissance Orbiter has been circling the moon since 2009, for example, but for some frustrating fits and starts notwithstanding, getting back to the surface was not a priority until recently. In December 2017, the then President Donald Trump ordered NASA to return astronauts to the moon in relatively near future. This directive gave rise to a broad and ambitious program called Artemis, which aims to establish a long-term sustainable human presence on and around the Moon by the end of the 2020s, and to use the knowledge gained in doing so to help astronauts get to Mars by the late 2030s or early 2040s. NASA's plans to set up one or more Artemis bases in the Moon's southern polar region, which is thought to harbour lots of water ice. Before sending astronauts there, however, the agency wants to collect more data about this little explored area to help determine, for example, just how much water it contains and how easy this crucial resource might be to access. So NASA has established another program called CLPS, which we talked about last week, the Commercial Lunar Payload Services, which books rides for agency science instruments on robotic lunar landers built by American companies. The goal here is for us to investigate the Moon in preparation for Artemis, and really to do business differently for NASA. Sue Lederer, CLPS project scientist at Johnson Space Center in Houston, said during a press conference on February 12th, "One of our main goals is to make sure that we develop a lunar economy, and that's where Intuitive Machines comes in." In 2019, CLPS selected Intuitive Machines to deliver a batch of NASA science instruments to the lunar surface using the company's Nova-C lander, which is about the size of a British telephone booth. After some modifications, the task order turned out to be worth $118 million. NASA officials said recently. It covered the transport of 6 agency experiments and technology demonstrations on Intuitive Machines' first lunar mission, which the company calls IM-1. That mission features a Nova-C vehicle named Odysseus, after the famous voyaging hero in Greek mythology. The NASA instruments, which cost the agency an additional $11 million to develop, are designed to conduct a variety of investigations. For instance, one of them, called NDL, Navigation Doppler LiDAR, for precise velocity and range sensing, used LiDAR, light detection and ranging technology to collect data during descent and landing. NDL turned out to be vital to today's touchdown, as you'll see in a second. Another instrument was designed to study how the spacecraft's engine exhaust interacts with lunar dirt and rock. Yet another will demonstrate the autonomous positioning tech, which could eventually become part of a broad GPS-like navigation system on and around the Moon. Intuitive Machines also put 6 commercial payloads on Odysseus for IM-1. One of them comes from Columbia Sportswear, which wanted to test its Omni Heat Infinity insulative material in deep space. Another is a set of sculptures by the artist Jeff Koons, and there's even a secure lunar repository that aims to help preserve humanity's storehouse of accumulated knowledge. Also flying on Odysseus was EagleCam, a camera system built by students at Embry-Riddle Aeronautical University. EagleCam was designed to deploy from Odysseus at about 100 feet or 30 meters above the lunar surface and snap photos of the lander's epic touchdown from below. All 12 of the included payloads lifted off on February 15 when a SpaceX Falcon 9 rocket sent Odysseus towards the Moon. The lander's deep space trek was short and relatively smooth, although things got a bit sporty towards the end. Odysseus arrived in lunar orbit on February 21 as planned, and in the home stretch of its touchdown, however, the lander's handlers discovered that Odysseus's laser rangefinders, which allow it to determine its altitude and horizontal velocity, weren't working properly, and the team pressed NASA's experimental NDL payload into surface for this vital function, pushing the landing try back by 2 hours to put a new plan into action. This last-minute workaround, which required the team to design the software patch on the ground and beam it up to Odysseus, did the trick, and at 6:11 p.m. Eastern Standard Time, Odysseus fired up the main engine for a crucial 11-minute burn that slowed the craft's descent down toward the lunar surface. Then, at 6:23 p.m. Eastern Standard Time, Odysseus touched down softly near the rim of the crater Malapert A, about 190 miles or 300 kilometers from the lunar south pole. Now, success wasn't immediately apparent, however. It took about 15 tense minutes for the IM-1 team to latch onto Odysseus' signal. What we can confirm without doubt is our equipment is on the surface of the moon and we are transmitting, Mission Director Tim Crane said after that milestone moment. Odysseus has found his new home. If all goes according to plan, the lander and its payloads will now operate for about 7 Earth days on the lunar surface. IM-1 will end when the sun goes down at Malapert A. The Odysseus was not designed to survive in the bitter cold of the long lunar night. It takes the moon more than 27 Earth days to rotate once on its axis, so each lunar night lasts roughly 2 weeks. IM-1 is part of a newly energised march to the moon. For example, Pittsburgh company Astrobotic launched its Peregrine lunar lander last month on the first flight of United Launch's Vulcan Centaur rocket, but Peregrine also carried NASA payloads via the CLPS program, suffered a crippling fuel leak just after deploying from the rocket's upper stage. The problem prevented Peregrine from making it to the moon, and Astrobotic ultimately steered it into a controlled demise in Earth's atmosphere on January 18. 2 other private moon landers made it to the lunar orbit recently, the Israeli Bereshit probe and the Hakuto R, which was built by Tokyo-based company iSpace. Still, neither one could take the next step. Bereshit crashed in during its landing attempt on April 2019, and Hakuto R suffered the same fate in April 2023. National governments are increasingly shooting for the moon as well. Last August, for instance, India put its robotic Chandrayaan-3 mission down near the lunar South Pole, and just last month, Japan landed its own moon probe called SLIM. It was the first such success for each nation. They've now joined the Lunar Party, which already included Soviet Union, the US and China, and some of these countries have even bigger lunar ambitions. There's the US with its Artemis program, of course, but China also aims to put astronauts on the moon by 2030 and is working with Russia and several other nations to develop a lunar outpost later that decade as well. India, meanwhile, has said it wants to put boots down on Earth's natural satellite in 2040 or thereabouts. Some politicians have characterised this planned activity as a new moon race, a competition between the US and China for the right to establish precedents and norms of behaviour in the high frontier. Exploration advocates, however, tend to see the rosier side, stressing the coming exploitation of lunar resources that could help humanity extend its footprint out into the solar system for the first time. Either way, the moon is coming into sharper focus. For the nations and businesses around the world, it's going to get busier and busier. So how about that, Hallie? ERS-2 has come down and Odysseus on the moon.
So essentially an umbrella won't help and a big sheet of steel won't protect you either.
From a falling satellite the size of a bus? No. But you were listening. The chances of being hit are so small that...
For you, I'm totally fine. I'm just electrons and light.
Okay.
You're going to need a concrete raincoat, I think.
Oh, Hallie, I think they know how to bring these old crates down safely. Honestly, I'm in more danger crossing the road.
What? From satellites?
No, from cars.
Why would cars fall from the sky when you're crossing the road?
Hallie, have you checked your power cells today?
Oh dear, I'm being silly in public, aren't I?
Say see you later, Hallie.
See you later, Hallie.
And just like that, it's all over for another episode of our podcast. Once again, thank you for joining us on Astronomy Daily. I look forward to catching you all next time. Bye for now.
Astronomy Daily, the podcast, with your host, Steve Dunkley.